Okay, so example 2, we are continuing this idea of plotting polar coordinates, except you'll notice here on our grid, we are measuring in degrees. Okay, instead of radians, we're seeing that all of our radial lines are measured out in degrees. So for some of you, this might actually feel a little bit easier. The idea is the exact same. In every single point, we're given a radius, right? That first value is our radius, and then we're given the angle measure for our theta value. Okay, so here we have point A with radius of 4 and theta of 540 degrees. So we'll go ahead and start this process in this very similar way as we did in the last video. We're going to start on our polar axis, and we're going to go and build an angle measure, a theta value of 540. Well, I know if I go all the way around my unit circle once, that's 360 degrees. If I go a quarter more, that's 450 degrees. And if I go 1/4 more, that's going to land me at the 540. So we have theta is equal to 540 degrees. And that takes us plotting, or has us plotting here on this radial line. That actually also corresponds to 180 degrees. We are told that our radius is 4. So on this radial line, we need to plot a point 1, 2, 3, 4 units out from the origin. So we will call this point A. Point B is a little less aggressive. This is kind of nice, right? We have just a radius of 2 and a simple theta value of 30 degrees. So up in our plane, our coordinate system, our polar coordinate plane, we are going to start on our polar axis, and we're going to build a theta value of 30 degrees. That's just sitting right here at that second radial line, and we have to build a point that is 2 units away from the origin. So we will plot point B at a R value of 2, theta value of 30 degrees. All right, point C, we have that R is equal to 3 and theta is equal to negative 150. So this tells us that when we go to plot this on or from our polar axis, we need to go in the negative direction, right? And we need to go until we hit 150 degrees. So I know that a quarter of the circle is 90 degrees. I need to go 60 degrees more, okay? So here's 30 more degrees, an additional 30 degrees here takes us to the radial line of 210 degrees. And we're told that we need to build that point 3 units out from the origin. So point C is right there. Okay, point D. This one maybe we should have started with. This is pretty straightforward at this point, hopefully for you guys. This is a radius of 1 and a theta value of 180. So we start at our polar axis and we build an angle measure of 180 degrees. That has us plotting here along this radial line. And we need to plot our point 1 unit away from the origin. So we can call that point, point D. All right, in E, we have a radius of 5 and a theta value of negative 90. So when we start at our polar axis, we will build in the negative direction an angle measure of 90 degrees. That lands us here on the radial line corresponding to 270 degrees. And we need to plot a point that is 1, 2, 3, 4, 5 units out from the origin. So point E is here. All right, last one for this example. We have the point 4, negative 120 degrees. So our radius is 4 and our angle measure is negative 120. So as we've seen at this point, right, we're going to be building in the negative direction. We start on our polar axes and we need to go ahead and build the negative direction 120 degrees. So a quarter of way through the circle is 90 degrees, 30 degrees more lands us here on this radial line that corresponds with 240 degrees. And we need to plot a point that is 4 units out from the origin. So here is point F. All right, so hopefully between these two videos, you have a good handle on how to point or how to plot polar coordinates in both radians and degrees. If not, if you're confused, please go ahead and send me an email and I'll get some more resources headed your way to hopefully clear this up a bit.